Hello students, myself Dr. Deepak Verma. In this video, I will explain different types of slopes, then the terms related with stability and use of slope, then failure phenomena of slope and different forces acting during failure of slope. First, slope. The slopes are unsupported inclined surfaces. These may be classified as finite and infinite. First, infinite slope. In this case, the slope is constant and the depth is unlimited. But the soil properties are uniform throughout its depth. The examples of infinite slopes are slopes of layered material or slopes of stratified deposits. Second is finite slope. In this case, the depth is limited. Also, in this case, base and top surface are fixed, but the soil properties are uniform or non-uniform at different depths. The example of finite slope are inclined face of embankments, excavation, earthen dams. Further, for stability and analysis of slopes, it is essential to know some terms. First is slip plane. It is also called failure plane or slip surface or failure surface. And slip plane, it is a surface of sliding. Second, sliding mass. It is a mass of soil within the slip plane and ground surface. Consider this figure. AB, it is the inclined surface. DB, it is the ground surface. If the soil mass slides along this line AB, then we can say AB, it is slip plane and the mass in between slip plane and ground surface is sliding mass. Next is shear parameters of soil. The shear parameters are C and phi, where C is cohesion and phi is angle of shearing resistance. So shear strength in terms of total stress becomes C plus sigma tangent phi, where sigma is total pressure. In terms of effective stress, the formula becomes C dash plus sigma dash tangent phi dash, where C dash, sigma dash, phi dash are in terms of effective stress. Next, factor of safety. Factor of safety we may determine as the ratio of shear strength of soil to the shear stress. When shear strength is more than the shear stress, in this case, factor of safety becomes more than 1 and the slopes are stable. But when shear stress is greater than shear strength of soil, then failure of slope occurs. There are different methods for checking the stability of, and these based on the experience and investigation. For analyzing the stability of slopes, we must know the failure phenomena and different forces acting on the slope surface. Consider this figure. In this figure, AB, it is the slip surface or the plane of weakness. And the failure of slope occurs when a part of soil mass or wedge slide along this specific plane. As shown in figure, this W, it is the weight of the sliding mass acting downward. Alpha, it is the angle of slip plane with the horizontal. L, it is the length of failure surface AB, that is this one. If we resolve weight in two component, then it is tangential component and it is normal component. And the angle between weight line and normal line, it is alpha, because alpha is here and we know the angle between two lines and angle between their perpendiculars is same. So it is horizontal line and perpendicular to this it is weight line. Similarly, it is a slip plane and perpendicular to this it is normal line. So the angle between these two lines is equal to angle between their perpendiculars. So by resolving the weight along the plane of weakness, that is tangential component, and normal to plane, that is normal component, so T equal to W sin alpha, we can determine by drawing the force triangle. It is W, second is normal component, and it is tangential component. So the value of T in terms of W is W sin alpha. Further, the forces resisting the sliding of solid mass are: first is cohesive force along failure surface, that is CL, where C is cohesion and L it is the length of slip plane, and second is frictional force. So we can determine the factor of safety by dividing resisting force to the sliding force. Resisting force CL plus W cos alpha into tangent phi divided by W sin alpha. The stability and slope may be determined by different methods, and these may be further classified on the basis of type of slope. First, stability analysis of finite slope. There are different methods: total stress analysis, method of slices, friction circle method, effective stress analysis, and also by Taylor's method, that is stability chart or stability number. In case of infinite slope, the methods are infinite slope in cohesionless soil, second in purely cohesive soil, and third in cohesive frictional soil. Thank you.